The inspector is indeed correct. THWN wire is not rated for continuous submersion in water. It's crucial to understand the limitations of different wire types to ensure electrical safety and code compliance. The National Electrical Code, or NEC, specifies appropriate wiring methods for various environments, and underwater applications have very specific requirements. THWN wire stands for thermoplastic high water heat resistant nylon coated wire. The key here is that while it is water resistant and suitable for wet locations, it's not designed for prolonged submersion. Wet locations, as defined by the NEC, are areas subject to moisture but not continuous saturation. Think of underground conduits that might accumulate moisture or condensation. THWN is acceptable in those scenarios when installed per code. However, submersion implies continuous contact with water, which is a far more demanding condition. The nylon jacket on THWN wire, while providing some protection, is not impermeable to water over extended periods. Water can eventually penetrate the insulation, leading to degradation of the wire's insulating properties and increasing the risk of electrical faults, such as short circuits or ground faults. When a conductor's insulation degrades, the risk of electric shock significantly increases because the wire can then energize anything it comes into contact with, creating an extremely dangerous situation. In the context of a boat lift, the conduit running underwater is inherently subject to continuous submersion. Even if it's not constantly underwater, the potential for prolonged exposure is high, especially considering tidal variations, wave action, and seasonal changes in water levels. Therefore, using THWN wire in this application would be a clear violation of the NEC and a significant safety hazard. The NEC mandates the use of specifically listed and labeled cables or conductors for submerged applications. These cables are designed with specialized insulation materials and construction techniques to withstand prolonged exposure to water without degradation. Some examples include submersible pump cables designated as SPT-1, an underground feeder, or OFF cables which are water resistant or even direct barrel rated. These cables typically have a thicker insulation layer made of materials that are less permeable to water, such as cross-linked polyethylene or XLPE or other specialized polymers. They may also have additional protective layers, such as a metallic shield or a rugged outer jacket, to further protect the conductors from physical damage and water intrusion. When choosing a cable for underwater use, it's essential to carefully review the manufacturer's specifications and ensure that it is specifically listed and labeled for submersion. The listing should be from a recognized testing laboratory, such as Underwriters Laboratories, or UL, or Intertek, which provides independent verification of the cable's performance and safety. In situations where the wiring is exposed to both water and mechanical stress, such as in a boatlift application, it's also important to consider the cable's mechanical strength and abrasion resistance. Cables with a robust outer jacket and reinforced construction can withstand the stresses of movement and contact with surrounding objects, further enhancing their reliability and longevity. It's important to consider the environmental factors when choosing a wiring method. Salt water is more conductive and corrosive than fresh water, which means that it can accelerate the degradation of electrical insulation and metallic components. Therefore, in marine environments, it's essential to use cables and connectors that are specifically designed for saltwater exposure. These components typically have corrosion-resistant materials and coatings that can withstand the harsh effects of salt water. The inspector's reference to underground conduits and high water tables highlights the distinction between wet locations and submerged locations. While underground conduits may be subject to moisture, they are not typically continuously submerged. The NEC permits the use of THWN wire in underground conduits as long as the installation complies with all applicable requirements, such as proper sealing and drainage. However, if an underground conduit is known to be continuously submerged, then a cable rated for submersion would be required. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated regularly to reflect new technologies, changing conditions, and lessons learned from past incidents. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations comply with its requirements. They play a crucial role in protecting the public from electrical hazards. When an inspector identifies a potential violation of the NEC, it's important to take their concerns seriously and address them promptly. Ignoring an inspector's warning can have serious consequences, including fines, project delays, and, most importantly, increased risk of electrical hazards. In the case of a disagreement with an inspector's interpretation of the NEC, it's always best to consult with a qualified electrical engineer or a more senior inspector. They can provide expert guidance and help to resolve the issue in a way that ensures both safety and code compliance. In summary, using THWN wire in an underwater conduit for a boat lift is a violation of the NEC and a safety hazard. The correct approach is to use a cable that is specifically listed and labeled for submersion, such as submersible pump cable or water-resistant wire. By following the NEC and using the appropriate wiring methods, one can ensure the safety and reliability of their electrical installation. For boat lifts, one must select a wiring method that is specifically listed and labeled for this purpose and is installed according to the manufacturer's instructions. This may include using a listed underwater cable assembly or a conduit system with watertight fittings and a cable rated for submersion. Proper grounding and bonding are also essential for boat lifts to minimize the risk of electric shock. The grounding system should be designed to provide a low impedance path for fault current to return to the source, which will cause the circuit breaker to trip and de-energize the circuit. Bonding is the process of connecting all metallic parts of the boat lift together to create an equipotential plane, which reduces the voltage differences between them and further minimizes the risk of electric shock. Regular inspection and maintenance are also crucial for boat lifts to ensure that the electrical system is in good working condition. This includes checking for any signs of damage or deterioration to the wiring, connections, and equipment. Any issues should be addressed promptly by a qualified electrician. Some additional considerations when wiring a boat lift include the following. Firstly, the location of the boat lift should be evaluated to determine the appropriate wiring method. If the boat lift is located in a saltwater environment, then corrosion-resistant materials should be used. Secondly, the load requirements of the boat lift should be calculated to determine the appropriate size of the wiring and overcurrent protection. Thirdly, the wiring should be installed in a manner that protects it from physical damage and water intrusion. Fourthly, all electrical work should be performed by a qualified electrician who is familiar with the NEC and local electrical codes. By following these guidelines, one can ensure that their boat lift is wired safely and correctly, protecting both people and property from electrical hazards. Additionally, it's important to understand the different types of insulation available for electrical wires and cables. THWN is a common type, but there are others, such as THWN, XHHW, and use, each with its own unique properties and applications. THWN, or thermoplastic high heat resistant nylon coated, is similar to THWN but is primarily used in dry locations. XHHW, or cross-linked polyethylene high heat resistant water resistant, has a higher temperature rating and is suitable for both wet and dry locations, but it's not rated for submersion. Use, or underground service entrance, is designed for direct burial in the ground and is resistant to moisture and sunlight. When selecting a wire or cable, it's important to consider the environmental conditions, the voltage and current requirements, and the applicable codes and standards. Using the wrong type of wire or cable can lead to premature failure, electrical hazards, and code violations. In addition to the wire itself, the connectors and fittings used in an electrical installation are also critical to its safety and reliability. Connectors should be properly sized and installed to ensure secure and reliable connection. Fittings should be watertight or weatherproof depending on the location to prevent moisture from entering the enclosure. All connectors and fittings should be listed and labeled for their intended use. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, which will cause the circuit breaker to trip and de-energize the circuit. Bonding connects all metallic parts of the electrical system together to create an equipotential plane, which reduces the voltage differences between them and minimizes the risk of electric shock. The grounding and bonding system should be designed and installed in accordance with the NEC and local electrical codes. Regular inspection and maintenance are also crucial for electrical safety. Electrical systems should be inspected periodically for any signs of damage or deterioration, such as cracked or frayed wires, loose connections, or corroded components. Any issues should be addressed promptly by a qualified electrician. By following these guidelines, one can ensure the safety and reliability of their electrical installations and protect themselves and others from electrical hazards. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always consult with a qualified electrician for any electrical work and never attempt to perform electrical work unless you are properly trained and qualified. Also, be sure to energize the circuit before working on any electrical equipment and always use appropriate personal protective equipment, such as insulated gloves and safety glasses.